Broadsword calling Danny Boy.
Okay, YouTubers, this is Joe from Martian TV, another game of Interplanetary I Spy going on here. Now today, we're going to have a very quick look at Mars rolling rocks, or moving boulders, or whatever you want to call them. Now, if you Google Mars rolling rocks, you'll get lots of images coming up, a lot of them the same one from different angles, but there are a whole bunch of these, and some of these so-called rolling rocks may well actually have rolled down a slope. But others I'm not so sure about. Now, this one here on the right, in the top right here, is one I've got up in my viewer, and I've zoomed in here. Now, this particular rock is quite unusual. Unlike some of the other so-called rolling rocks, it seems to be quite tall and quite pointed, as you can see by the shadow. Now, obviously, the shadow is probably a bit of an oblique angle there, so it's making it look probably, the shadow may be twice as long as the object is high. Don't really know, hard to say exactly, and also this may well be on a slope, and this may have just kind of gradually rolled down over this area towards the right here, and this may be sloping towards the right, so we don't actually know what the elevation of this is. But there is another explanation, and recently I did watch a documentary on the Discovery Channel or something about moving rocks on Earth, and it's long been a mystery, and they tend to happen on flat mud in salt lake areas and places in the US and various places around the world, and we're often attributed to high winds. Now, the problem is on Mars, we are told it's quite windy up there and you get dust storms up there, but actually if the conditions on Mars are what they say they are, and the atmospheric pressure is a fraction of what it is here, it would be very hard, even if the wind was 300 miles an hour, there would not be enough pressure in the air for it to move much, because the air pressure is way too low. So, I mean, the winds would have to be a great deal more than a few hundred miles an hour up on Mars for them to move large rocks. And some of these rocks are quite large. But there is another explanation. And on Earth, on various flat areas like evaporated salt lakes and that kind of thing, what tends to happen is you get a large amount of rainfall overnight, followed by a freeze, and basically you get a sudden shower which will flood the plain area or the flat area with water, which may only be a few inches deep, and then this, on top of the water, you then get ice forming as the temperature drops at night, and then at some point the next day, in the morning perhaps, the wind then pushes the ice, which breaks up into like large pieces, with water underneath this ice. So you have a layer of water with a thin layer of ice on top, and the wind then blows this ice like mini icebergs across the surface of the liquid water. And these small icebergs or pieces of ice, whatever you want to call them, then push the rocks along. Now, this is the scientific explanation for this behaviour on Earth. So I would assume that on Mars it would be similar. Now, this proves the existence of liquid water on Mars, of course. Now, this one may have rolled down a hill, but there are many other images. I haven't got loads of them up here. There are many other images of rolling rocks. And that one was the most interesting, because this dark patch here looks to me like a wet patch of sand or sediment or whatever it is. So it looks like water flow that's soaked into the sand, and the rock may have moved during this wet period. Some ice may have melted up here on the far left, and the water run down, and as it ran down, it could have, the ice and water may have pushed this rock along. So it does kind of fit that hypothesis. So, okay, we won't spend too long now. I'm just going to quickly show you some pictures of water on Mars, just for those of you who think there is no water on Mars. There's plenty of evidence of water on Mars. Here's a NASA hydration map here somewhere. Here we go. Here we go. And now this is not a hydration map. This is a gamma ray spectrometer map of Mars showing the basic water table of Mars. And as you can see, the dark blue at the top and bottom here, the polar regions, are 70% water. And the yellow and red areas in the middle are 1 or 4% or whatever water in these areas. Now, the Gale Crater is in one of these equatorial areas. It's not shown on here, but it's up here somewhere on the right, I think. And so the water levels in Gale Crater are probably only around 4 to 7%, possibly less. We're told it's only 2% water on Mars, but that's not the whole of Mars. This is a complete lie. This is one of NASA's own diagrams here that shows H2O, and it clearly shows here that the polar regions are absolutely covered in water. It may well be frozen, but it's still water, and microbial life can survive in frozen water. It lives in microbial life on Earth lives in water in all its states, whether it's frozen or not. So I would fully expect there to be microscopic life in some of this water, and especially in the melt zone areas, not right up in the north or south poles, but these temperate zones around 30 degrees latitude here, which are in between the hot and cold areas. Now, these are what are called melt zones. This is where the ice melts regularly every year, and large parts of Mars, sometimes the size of Texas or whatever, do go green every year, and this is due to meltwater flooding into these areas, and possibly grass and lichen and other possibly other organisms, green organisms growing like algae or something. So this is entirely feasible. So that's the water table. It's well worth just look up water table Mars, and this will probably come up on Google. You don't have to look too hard for it. There are other things I've got here. There's a temperature map. Now this is not a very good quality picture, so I won't zoom in too far. This shows the minimum and maximum temperatures throughout the year, roughly, which I do think may be a bit off in some cases, but it goes down to about -80 at the coldest in the winter here, and in the summer the minimum temperatures are around -40, about -40. So it does get very cold on Mars. So there is ice up there, of course, but not all of Mars is the same temperature, and this is what people need to understand. Mars is a complex setup where it also has quite a distinct wobble in its path around the sun. So the seasons on Mars could vary quite a lot, and we haven't really been there long enough to determine the actual true climate of Mars, and we're not really being told exactly what it's like. I really do think we are being quite badly lied to about liquid water on Mars and the atmospheric pressure. Now this is another Mars image. I think this is from the Mars Reconnaissance Orbiter. I'm not sure the HiRISE this one is, I think. Yeah, this is HiRISE. Now ignore that square there, that's just where I've used the image before. Now this is what looks like water on Mars, liquid water on Mars. Now there is a little bit of difficulty in interpreting this, because there are lots of sand dunes down here that are blue, mixed with kind of red sand as well, and a lot of this is sand, but I really do think on looking at this again that there are sand dunes, but there is water as well in this area. And if you look at this rock here particularly, it has a wake behind it, as if the water is kind of running into it. And also sand is not reflective, and you can clearly see here you've got this large rocky outcrop here, like an overhang in this sort of on the edge of this mountain here, and you've got the shadow underneath this overhang, but you also have a dark patch down here in this blue. Now that to me looks like a reflection. Now we're not seeing a very prominent reflection here because of the angle that we're viewing it from. But water is reflective, much like glass, and this much darker blue part here is mirroring this dark overhang here. So this is water, this is liquid water. If it wasn't liquid water, we would not be seeing a reflection. Now the reflection isn't in any great detail, and from this angle it wouldn't be. But this looks like water. There are lots of other images I have here. I'll put links to some of these in the description. There's a hydration map here of this is Gale Crater. This is where the Opportunity rover is, and you can see here the hydration is marked in blue. Now this is wet. This area is wet. Now, if there's no water on Mars, then why is this area blue? They've marked it blue to show the level of hydration. So you've really got to see through a lot of the crap that we're told by NASA, because I really do think people are being misled, and they're not. You've really got to read through the lines, between the lines, to really work out what's going on. And there are these other images here from Mangavallis region. Now this is on Mars. Mangavallis, I should say. A bit hard to say. A lake. I mean, what else could this possibly be but a lake? You even have here a big wave and another wave here. Like there's a sort of tidal wave, or just waves coming in. Now I don't know the scale of this, so I have absolutely no idea what scale this is. But it looks pretty big, and it looks like something from Google Earth. This is water, liquid water. Ice is not blue. Ice when it freezes, because of its oxygen, the water has quite a high oxygen content, it goes white because of the amount of gas in the water. So ice generally is white, not dark blue like this. This is water, and you can even see through it here what looks like some sort of algal bloom here, perhaps, or just some sort of sediment coming into the water. Not really sure what that is there, but it looks like a lake. And all you have to do is look these things up. There are lots of lakes on Mars. There are rivers on Mars. There are moving rocks on Mars that are being pushed by ice, which must be on top of liquid water, as I've already explained. This hydration map does show. This is the gamma spectrometer. This shows the temperatures. Okay. Now, but the hydration map is interesting, and there's another radiation map here showing the different temperatures. So temperatures on Mars vary drastically between the poles and the equator, as they do on Earth. So don't pay too much attention to average temperatures, because they're very, very misleading. And in Gale Crater, as I have said many times before, Gale Crater is 4.5 kilometers down. It's not subject to normal surface temperatures. It also shows signs of a large amount of geothermal activity, and is likely to have warm liquid water, much like in this image here, where you have what looks like steam rising. Ignore this bit. I used this for a previous video and selected that area. But look at this white steam rising here. This is thermal activity. Either it's thermal activity, or NASA are airbrushing these images to hide some of these structures in here, which there is. You can actually see a triangle here. There's what could be a pyramid or something in there, and there's also the Mars obelisk, which I've covered in previous videos, just here. So look that up, and do go to my. I mean, that's a real cool thing. That's one of my favourite finds, the Mars obelisk. Go if you want to check some of these out in greater detail for a bit more information. Check out my my YouTube channel. I've got quite a lot of playlists on here now, and this will be in the Mars Water, Lakes and Rivers playlist, and you can see that obelisk in more detail there. So that's well worth checking out. And also, I mean, the Mars crocodile video also shows signs of liquid water melting off the rocks in Gale Crater and actually dripping into the sand, and you can actually see wet patches in the sand below this potential crocodile here. I mean, it's probably not a crocodile, but actually this video is more about the water, really. As obviously the cold weather on Mars, even in Gale Crater, which is very warm, at night gets very cold. The moisture in the air condenses into ice on the rocks, and then when the rocks warm up the next day, it then melts. So you have liquid water, and in those conditions, it is possible for plants like lichen and maybe moss to grow. And if there's lichen and moss, then there are probably small creatures that eat lichen and moss on Mars. And then there are probably slightly bigger creatures that eat them. So you have a potential for a food chain here. Once you have liquid water, which there is on Mars, then you have a possible food chain. And I find it extremely hard to believe that there would be no life in liquid water on Mars, because Mars is in the Goldilocks zone, and I really do think that the atmospheric pressure on Mars is much greater than we are being told. Because for these phenomena to happen, and they do happen quite a lot, and not all these rocks are just rolling down the hill because it's on the slope, they are moving along flat surfaces, and the only possible way that can be is if there's greater atmospheric pressure, which means the wind is more powerful than it is supposedly now to push these rocks along, and there must be liquid water on the surface which freezes and then defrosts, and you have large sheets of ice pushing these rocks along the flat surfaces, as I explained earlier. So this is evidence for liquid water on Mars, and there are many photos, as I've shown you a few here, but check out my other videos, like I said, and you can see some of this stuff in more detail, and I go into a little bit more detail about this. So there we go. I'll just show you those playlists again up here. Where are they? Here we go. So yeah, the one you want to check out is Mars Water, Lakes and Rivers, and in fact there's a lot that contain this sort of water information, but that's the main one to look up there. Also, one of my recent videos, Mars Explosion 1941, does go into some detail about water on Mars as well. So thanks for watching, everybody. Another game of interplanetary I Spy gone slightly awry. Thanks for watching, and I'll see you soon.